Section 10.4.5. To test the null hypothesis where the population standard deviation is equal to 2.5 versus the alternative hypothesis where the population standard deviation is greater than 2.5, a random sample of size n is equal to 20 is obtained from a population that is known to be normally distributed. We're going to complete parts A through D. Well, first and foremost, let's take a look. It says greater than. So we need to know that because this represents greater than, we know this is going to be a right tail. Okay. Now, in part A, it says if the sample standard deviation is determined to be S, which is equal to 3.1, we're going to compute the test statistic. So here's our formula for the test statistic. And so what we need to know is, first we need to know what is the sample size. Well, the sample size that's given is 20. And we know that the population standard deviation in the null and alternative is equal to 2.5. And then we're given the sample standard deviation S to equal 3.1. Now we're going to plug it into our formula. So we know that n is equal to 20. We're going to subtract 1, multiply that by the sample standard deviation of 3.1 squared, divided by the population standard deviation, which is 2.5 squared. Okay, so let's go ahead and put that in our calculator. Okay, so we have 20 minus 1 times 3.1 squared. And then we're going to divide that by 2.5 squared. So we get the following number. Okay, and then we're going to round that to 3 decimal places. So that's going to give us 29.214. So the test statistic that we end up getting is 29.214. Okay, now in part B it says if the researcher decides to test this hypothesis at the alpha equals 0.025 level of significance, determine the critical value. Okay, so there's a few things that we need to first determine here. Okay, well, one, we need to find out what are the degrees of freedom. Well, the degrees of freedom is taking the sample size and subtracting 1. So we know that our sample size is 20, and then we're going to subtract 1 to get 19. Okay, and then number 2, we're given the fact that alpha is going to equal 0.025. Now, this is a right-tailed test. So that means we're looking for chi-squared, which is alpha, and that chi-square has an alpha of 0.025. So, what do we need to note in order to find the critical value? So, we're going to go ahead and take a look over here. We know that we have 0.025. And we know that the degrees of freedom is going to be 19. So if we take a look there, we end up getting a critical value of 32.852. So therefore, that's going to represent our critical value. Okay, now part C, it says draw the chi-square distribution. Okay, so we know that from the beginning that this is going to be a right-tailed distribution. So we're going to draw our graph. We know that we have this bell curve that is skewed right. Okay, you go ahead and redraw that again just to make this a little bit clear here. So what we need to do is we need to find out, okay, where is the critical value located on our distribution? So our critical value here, okay, that we got is 32.852. 32.852. Okay, and then we know that everything to the right, since it's a right tail, is now going to represent the critical region. Okay, so we can answer part D by looking at this graph. And what I mean by that is, okay, well, where is the test statistic? Well, our test statistic is 29.214. And that is to the left. So this is where the test statistic is 29 point, again, it's 214. Okay, so this is the test statistic that we found in part A. So now we need to know whether the researcher is going to reject the null hypothesis or not. Okay, well, the researcher will reject the null hypothesis if the test statistic falls within the critical region. And so if we compare the test statistic versus the critical value, we can see here that the test statistic 29.214 is less than 32.852. So it, or we can say not it, we can say the test statistic does not fall into the critical region. And so therefore we do not reject the null hypothesis. So therefore, we would say that the researcher cannot reject the null hypothesis.